Good morning. So I'm going to do another video that sort of is looking at this quark thing again, or the three axes of quark nature and reality. So on this program GeoCalc, I just plugged in, if you can see that, there we go, equation for a sphere basically. Only I have an adjustment factor along one of the axes. So we take a sphere and let's just so that's flattening the sphere. We're going to lengthen it, and then we're going to go beyond catastrophe. And when you basically the inversion or the eversion of a sphere is this cone. That. There we go. So let's say that so this smallest part here, right, this little sphere, right in there, is the point of convergence. That's like the plane of convergence. So if we look relative to that, like if we were looking down on this, that sphere could be positive. But everything that we see, because we're looking down onto it, would be the negative aspect surrounding that positive sphere, the electron cloud, so to speak. I have to get this proportionality right. I haven't figured out exactly what the math is for that because lazy. Anyways, but fundamentally, this is the thing, and let's expand out, right, because that's like huge. But if it was a point particle, oh, it's just like a field cone along one axis. Let's add another axis. There we go, second axis. Let's add a third axis. Boom. Okay, I colored all the axes differently. So there we go. So that would be all the axes, and this is where it's like fully expressed. And now I'm going to take it back again. Oops, sorry, was I way off? I was not paying attention. I need to be on camera. There we go. So this is with all three axes, right, being expressed. This would be like the electron field, and it would look like a sphere to us with a drop-off proportional. And then let's shrink it up. All right, so we can see them a little clearer. There we go. There's our axes of charge, which are divergent from where we look, but convergent, all convergent on the center point, which is the proton. So let's expand that up a bit again. There we go. Okay, so now I'm just going to bring it for a second, if you will. So this is it. We're going to bring it down until it's contained. There we go. But still, this would be like axes. So we could say like this was the proton, and the other form, the expressed form, would be the reciprocal electron negative charges. There's this interesting phase change that I addressed in a previous video, but I thought since we're looking at these quarks, we can do it again. Okay, so there it is. And now we're gonna, oops, bring it down, bring it down, bring it down, bring it down, bring it down. Okay. Now, right now, I'm going to also bring up, just so we can see the sort of the different sections more clearly, so they're not transparent. That was before, so that we can just see it more as a field. Let's set these to opaque. Boom. Okay. So this is the way the field goes, right? There's like basically a cone going out of this end, a pole going up there, that would go across the universe and come back in there. Red there, that would come back in there, yellow there, that could come back in there. This is like sort of like a electrical field 101, right? The field goes out forever, or magnetic fields either also. Okay, so there we go. Now I'm going to sort of continue bringing the field, instead of being an expressed field, bringing the field down inside itself, right? Okay, and now we keep on going, and we keep on going, and we keep on going. And there's this weird phase transition where it's like from the proton, it's like if this was a neutron and the neutron decomposes, and now it's got charges. Whereas when it's like this, if you notice, this is a dodecahedral. It's a rhombic dodecahedron. For all those people that are excited about rhombic dodecahedrons, because it does represent, it's like, look at it, it's like a ring of blue, so that a field coming out of here can close itself off there and there. It's a very contained field structure. These arcs would go from red to red to red to red to red. It would just be like a little rings intertwining, but very self-contained, whereas this, the blue has to cross the entire universe basically to get to the other blue. But here, it's already practically touching itself. I just thought this was a very interesting, it's very simple geometry. And then this was a dot to represent like the mass that initially would have started this whole process of convergence that creates the charges, etc. But I just thought this was a very interesting, hello Patrick, thank you. I just really think this is very interesting, this phase change. Like, of course, it's like an artifact of computation or something, but it's just, I don't know, it's just tweakish. Anyways, peace.